Recursion and financial modeling. Question 5. Alex is a mobile mechanic. He uses a van to travel to his customers to repair their cars. The value of Alex's van is depreciated using the flat rate method of depreciation. The value of the van in dollars after n years, Vn, can be modeled by the recurrence relation shown below. Part A. Recursion can be used to calculate the value of the van after 2 years. Complete the calculations below by writing the appropriate numbers in the boxes provided. Using the recurrence relation, V1 equals V0 minus 3,375. So 3,375 is the number in the first box. V2 equals V1 minus 3,375. V1 is 71,625. Take away 3,375. The answer is 68,250. This question is worth 2 marks. 1 mark could be for the value of 3,375 in the 2 boxes and the second value for the final answer. Part B, I. By how many dollars is the value of the van depreciated each year? Since 3,375 is subtracted from the value of the van of the previous year, the answer to this question is $3,375. This question is worth 1 mark for the correct answer. Part 2I. Calculate the annual flat rate of depreciation in the value of the van. Write your answer as a percentage. 3,375 out of 75,000, which is the initial value of the van, times 100 is equal to 4.5%. This question is worth 1 mark for the correct answer. Part C. The value of Alex's van could also be depreciated using the reducing balance method of depreciation. The value of the van in dollars after n years, Rn, can be modeled by the recurrence relation shown below. At what annual percentage rate is the value of the van depreciated each year? Since the value of the van is 0.943 of the previous year, that is 94.3%. So the depreciation is 100% minus 94.3%, which is 5.7%. This question is worth 1 mark for the correct answer. From the 2017 VC examination report, some students gave 9.43% or 94.3% as their answer. Question 6. Alex sends a bill to his customers after repairs are completed. If a customer does not pay the bill by the due date, interest is charged. Alex charges interest after the due date at the rate of 1.5% per month on the amount of an unpaid bill. The interest on this amount will compound monthly. Part A. Alex sent Marcus a bill of $200 for repairs to his car. Marcus paid the full amount 1 month after the due date. How much did Marcus pay? Marcus paid $200, which was the initial bill, plus 1.5% of $200. Notice that 1.5% is the interest rate per month. So the answer is $203. This question is worth 1 mark for the correct answer. From the 2017 VC examination report, many students did not read that the given interest rate was per month, So $200.25 was a common incorrect answer. Alex sent Lily a bill of $428 for repairs to her car. Lily did not pay the bill by the due date. Let AN be the amount of this bill n months after the due date. Part B. Write down a recurrence relation in terms of A0, AN plus 1, and AN that models the amount of the bill. A0, which is the initial amount on the bill, is 428, and AN plus 1 equals 1.015 AN. This question is worth 2 marks, 1 mark for each correct answer. From the 2017 VC examination report, many students did not write a recurrence relation in the required form. A recurrence relation has the initial value written first. Some students did not recognize the difference between the recurrence relation above and the rule AN equals 428 times 1.015 to the power of n. Part C. Lily paid the full amount of her bill 4 months after the due date. How much interest was Lily charged? Round your answer to the nearest cent. We can calculate A1, A2, A3, and A4 using the recurrence relation. To calculate the interest, we subtract A4 minus A0. 454.264 minus 428 gives us $26.26, correct to the nearest cent. This question is worth 1 mark for the correct answer. From the 2017 VC examination report, some students who answered parts A and B correctly gave $454.26 as the answer here, which was the total amount Lily was charged rather than the interest. An answer to the nearest 1 cent was required, not the nearest 5 or 10 cents. Question 7. Alex sold his mechanics business for $360,000 and invested this amount in a perpetuity. The perpetuity earns interest at the rate of 5.2% per annum. Interest is calculated and paid monthly. Part A. What monthly payment will Alex receive from this investment? We need to calculate 5.2% of $360,000, but we divide this by 12 because we want the monthly payment. And this gives us $1,560. This question is worth 1 mark, and this is going to be for the correct answer. From the 2017 VC examination report, some students gave the annual payment of $18,720, while others knew the correct method but rounded 5.2 divided by 1200 to 4 decimal places before multiplying by $360,000, giving an answer of $1,548. Part B. Later, Alex converts the perpetuity to an annuity investment. This annuity investment earns interest at the rate of 3.8% per annum, compounding monthly. For the first 4 years, Alex makes a further payment each month of $500 to his investment. This monthly payment is made immediately after the interest is added. After 4 years of these regular monthly payments, Alex increases the monthly payment. This new monthly payment gives Alex a balance of $500,000 in his annuity after a further 2 years. What is the value of Alex's new monthly payment? Round your answer to the nearest cent. The answer to this question is a two-step answer. The first step would be to calculate the balance of the annuity at the end of the first 4 years. Using available CAS technology, we are going to use TI Nspire. We add calculator, and then from the menu, we choose Finance and then Finance Solver. N is the total number of periods, so that is 4 years times 12 months is equal to 48 months. The annual interest rate, I, is equal to 3.8%. The present value is the annuity investment, which is $360,000. The monthly payments are $500. Notice that PV and PMT are both negative. We don't know the balance at the end of this period. The number of payments per year is 12, and the compounding periods are 12 as well. We can now calculate the balance at the end of the 4 years, and we can move to step 2, which is calculating the new monthly payment during the next 2 years. This time N is equal to 24 because it is 2 years times 12 months. The interest rate is the same, 3.8%. The present value is the future value from the previous step. The future value we know from the question is $500,000, and the number of payments per year and compounding periods are both 12. So the new monthly payment is $805.65. This question is worth 2 marks. Each mark would be for the future value at the end of the first 4 years, and the second mark would be for the new monthly payment.